Welcome to my online class, Mrs. C Math 2 class. Today's lesson would be simplifying radicals. Please free to use my PDF file that will be attached on this video. The PDF page or these examples can be found on pages 9 to 10. All right. So before we proceed to our final main topic, let's have an introduction of these two so you will have an idea what am I talking about and it will be related to this. All right, let's think of a number or what are those perfect square number. So let's begin at 1. 1, if you square root of 1 is 1 because 1 times 1 is 1. Another number would be 4, which says square root of 4 is 2 because 2 times 2 is 4. So to get 3, you need to multiply 3 twice. 3 times 3 is 9. So that's the third perfect square number. To get a 4, the next one would be 4 times 4. That will be 16. Next will be, I think you're guessing it. That will be, yes, you're right, 25. Next to that will be 6, which is 6 times 6 is, very good, 36. See, now you're learning. To continue, what's next to 6? That will be 7. So 7 times 7 is 49. 8. 8 times 8 will be 64. 9 times 9 is 81. And then 10 times 10 is 100. See? And there's a lot. Okay? You may add and keep this going. Next, perfect cube. You may start thinking of a number that 1 is a perfect cube because the cube root of 1 is 1 because 1 times 1 is 1 times 1 is 1. Next would be 2. If that is 2, 2 times 2 is 4 times 2 is, that you are correct, is 8. Now, if you think that would be bigger, it's better for you to use calculator. So this is 1, this is 2, and 3. So you're going to multiply 3 times. So times 3 will give you 27. I know you can see this, but if I'm going to look closely. So 4 times 4 times 4 is equal to 64. So that's the next perfect cube. Followed by 7, 1, 2, 3, 4, 5. 1, 2, 3. I multiplied 5 3 times, and that is 125. Now, you may keep going. You may continue this. If you have a calculator, as what I said, you can list all the perfect cube that are possible. Next will be perfect fourth root. How will I know the perfect fourth root? Let's start with 1. Is it 1 times 1 times 1 times 1 is still 1? The answer is yes. So 1 is a perfect fourth root also because as what I said, fourth root of 1 is 1 because 1 times 1 times 1 times 1 is 1. Next to that would be 2. So we're going to multiply 2 4 times. 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16. So this will be 16. Next is 3. So we are multiplying 3 4 times. 1, 2, 3, 4. So that will be 9. This will be 9. 9 times 9 is 81. So next will be 81. Next to this will be 4. So let's multiply 4 times. 4 times 4 times 4 times 4 will give you 16. That will be 16. 16 times 16 is a big number. So you may use calculator. I think that's 256. I'm not sure. It is correct. So that will be 256. And so on. Again, 1, 2, 3, 4. So that will be 5. If you multiply 5 4 times, 2, 3, 4, that will be 620. And as what I said, you may keep going until you list down all the perfect cube. Oh, perfect fourth root, I'm sorry. Next is to learn about what are the parts of radical. So there's always like a symbol to represent a certain parts of this radical. So to start with, this small letter N here will be known as your index. Remember that an imaginary index is 2. If you don't see anything on it, that will be 2. Next, this A here, under the radical symbol, or whatever is under the radical symbol, is known to be your radicand. Radicand, all right? And this symbol right here is a radical symbol, all right? Now, let's make an example. Let's proceed here. This will be read as square root of 5m squared. How did I know that this is a square? Because as what I said, if you don't see an index number, that means it is 2. So that's why it is a square. So square root of 5m squared. So again, this will be your radical symbol. And this will be your, what this is? This is your radicand. And your index is 2. Next, another example. So here, our index is 3. This still be your radical symbol. So this would be cube root this time because of the index 3. Now, your 4x raised to the 5th power will be your radicand. Now, exemption. Anything under the radical symbol is a radicand. Now, what about this 3x out of the radical symbol? This is known to be your, just like an algebraic expressions or an expression. If it is just a number, it's a whole number. All right. Now, let's go and proceed to simplifying radicals. So, square root of 117. How did I know that it is a square root? That's what I said. If there's nothing on it, that would be a perfect square. So 117, we need to break down 117 and think of a factor that contains a perfect square. See, now we are using these things because it is related to what our main topic for today. So 117, is 117 divisible by 4, by 9? So I will just use my calculator and let us see. So 117, let's see if it is divisible by 9. Yes, it is. So 9 times 13. So I will break it down by square root of 9 and square root of 100, or 13. So they're still both under the radical because they are not simplified yet. Since 9 is a perfect square number, and as what I said, you can take 9 by multiplying a number to itself. So 3 times 3. So in order for you to get the factor of 9, that will be cancel 1 and take 1. So once you take it, you need to put it outside the radical symbol. So the answer for this would be 3 square root of 13. Radicand 13 is not a perfect square. So it needs to be still under the radical symbol. So this will be your answer. Got it? Next. 4 is a whole number and it's still a square root of 320. So we need to think of a factor for 320 that is a perfect square. And I think, I'm not sure, but we can see and we can check. So 320 divided by 49 is not a perfect square. So 320. So this is trial and error divided by 64. Yes, it is. So 64. So I will put square root of 64 here and square root of 5 because 64 times 5 is 320. Now I will put down 4 here. I will just copy 4 here. Okay. So break down 64. 64 can be break down by multiplying 8 times 8. So to get that, you need to cancel 1 and take 1. The one that you encircle should be outside the radical symbol. And since we have a whole number outside, you need to multiply these two. So 4 times 8 times the square root of 5, which is the extra radicand or not a perfect square, or also known as a prime radicand, will stay inside. So 4 times 8 would be 32. All right, let me check. So the answer will be 32 square root of 5. So that's it. I hope you got it. Next, 2 cube root of 48. Why is it cube root? That's what I said. Your index is 3. So you're going to look at here. Now, cube root of 48. 2 will be a whole number, so I will just copy it. We need to think of a factor for 48 that is a perfect cube root. What do you think is the number divisible by 48? Let's see. 48 divided by 8 is, yes, it is divisible by 8. So, we will multiply, we need to split this by cube root of 8 and cube root of 6. Now, 8 is a perfect cube, so we need to make this split into 3. So what is that number? Once you multiply 3 times, the answer is 8, and that will be 2. Okay, so cancel 2, take 1, and put it outside, and then whatever the remaining or the leftover radicand will be copied. So the answer for this will be, not yet, because we need to multiply 2 on this. So that will be 2 times 2 is equal to 4. So hold on with the 4. And then I will copy this. So the answer will be 4 cube root of 6. So this is the correct answer for that. If you have any question, comment below and I will be happy to answer all those concerns. Let's proceed to number 4. 3 cube root of 108. I don't know what makes 108 perfect cube, so we need to think. 108 divided by 27 is 4. All right. So it's just my guess, but my guess is like good enough to do this. So cube root of 27 and what? 4. Cube root of 4. So bring down 3 here. Okay. 27 should be break down into 3. Split into 3. Why? Because the index tells us how many times you're going to break it down. So that will be 3 times 3 times 3 is 27. So cancel 2, just take 1 representative, and that will be 3 times 3 is equal to 9. And then copy cube root of 4. The answer is 9 cube root of 4. Next, 4th root of 81. So this time, your index is 4. It only means that we need to break down this radicand into 4. So what will be that number once you multiply it 4 times? The answer is 81. Let's see. I would say 2 times 2 times 2 times 2 is 16, not that. So 3 times 3 times 3 times 3 is 81. I think 81 is good. All right. So you're going to multiply 3 times 3 times 3 times 3. That's what I said. Cancel those 3 and just take 1. So the 4th root of 81 is equal to 3. Got it? Last would be 5th root. 5th root of 1. It only means that you need to multiply or split 1 into how many times? You are correct, 5. So 1 times 1 times 1 times 1 times 1. Cancel 4, take 1. The answer is 5th root of 1 is equal to 1. If you have any questions, just comment below and I will be happy to answer all your concerns. Next part would be simplifying radicals with variables.